Last week we learned about thermal diffusion, and today we want to use a stir plate to create vortex diffusion. So over here we've got a vortex started with our stir plate, and James is going to add some food coloring. We're going to see how quickly that vortex diffuses food coloring. So James, when you're ready, add the food coloring. Okay, back up. And you can see how it goes straight down and it diffuses almost instantly. Vortex diffusion. And we can also use a stir plate and a vortex to diffuse different chemical reactions. And so we're going to do a redox reaction next with potassium permanganate and see how quickly that diffuses it during a chemical redox reaction. You ready?
Yeah.
All right, here we go.
Where?
And now we're ready for part 2 of our vortex diffusion experiment. And this involves potassium permanganate that we have right here, and sodium hydroxide, some water, and a little bit of sugar right here. And some chemists call this the chemical chameleon experiment. This is a redox reaction where potassium permanganate actually gains electrons and loses its color. So at first it'll be bright purple, and then slowly it'll change. And so Mason Smith, would you come on up here, and let's have you add just a very small amount of potassium permanganate into our flask here. There you go, dump it in there. Good. And if you just hold that up and just swish it around with your hand, and people can see how purple that potassium permanganate is. Very purple. See how he's swishing it around? He's diffusing it until it reaches a state of, until it becomes completely homogeneous. That's perfect, Mason. Okay, set that down. Okay. And then the second part of this, Camry, come on up here. Camry, you're going to add our sodium hydroxide here, this cup. And you're going to pour that into the vortex and just let that diffuse. That's right, Camry. Perfect. Okay. And then the next one, Camry, you're going to add our sugar right into here. That's excellent. And we're going to let that sodium hydroxide and sugar mix in there until it becomes homogenized and we can't see the difference with those crystals. Okay? Now the other thing that we want to use is a lot of light to see the shift in color from our potassium permanganate. As it gains electrons, it's not going to be this dark purple color. It's going to actually be used up in effect and change. And so in order to do that, we're going to use this big floodlight over here, and that will allow us to see the big change of color. So here's our light. Okay, that way you can really see it. And to demonstrate this, friends, I want you to pay really close attention to the change of color. That's the neatest part in this diffusion reaction, this redox reaction, as it spreads out. And I'm going to have, let's have Hansla in the back. Hansla, why don't you come on up? Hansla, you're just going to pour the flask of potassium permanganate into the mix, and we're going to watch it slowly gain electrons. So go ahead and take that, Hansla, and pour it in. Pour it on in there. All of it. That's good. Perfect, Hansla. Okay, and back up. And let's watch it change color. So right now it looks very, very purple. And you should see a few different colors. It should start turning kind of green. In fact, over there, Mason Crowley, would you turn on that middle light switch so you get a little backlight? That'll help our video. Okay, so right now you can kind of see it turning almost like a blue-green, but it's not purple anymore, is it? There, I'm getting a better view of it. Now, as it gains electrons in this reaction, it'll change again until it's almost like a light copper or a light orange color. And basically, the longer you allow it to gain electrons and use up the potassium permanganate, the more dramatic it is. You can see it starting to lighten up. And the longer, oh, that's a better view of it. And the longer you let it go, the more you'll see that change. This is called the chemical chameleon in RamZland. And we're checking back in with our chemical chameleon. And Hansla, we started out with a pretty dark purple solution, didn't we? A potassium permanganate. And then it turned kind of a green, then kind of a blue. And now you can see almost a yellow color to it. It's changed quite a bit as it gains electrons and uses up that potassium permanganate.